Thank you very much, Christos, for an excellent talk. I have quite an act to follow here, so we'll see whether I can rise to the challenge. Without further ado, let's talk about testing Java 7 applications. Anyone here know how old Java 7 is approximately? We're looking roughly Windows XP, Windows Vista days. So yeah, that's a challenge. Before we get into that, let's talk about who I am. My name is Miłosz Gaczkowski. In my past life, I did some teaching at university, mostly University of Southampton, and my task there was kind of to herd 20-something-year-olds and help them come out at the end of it with a little bit more knowledge than they came in. In my current life, I'm the mobile security lead here at Reversec, which means that most of the time I'm surrounded by about 5 to 10 mobile phones on my desk, and I get confused about which one of them is which, and which one of them I use for communication, and which one of them are actually my job. Always exciting stuff. I also dabble in IoT and thick client testing. We'll get into thick clients in a moment, but think sort of an application on the desktop rather than a web application. I have many opinions. Anybody who dares to have a conversation with me afterwards will find out very quickly. Opinions are aplenty. So today's talk, despite my role as mobile lead, has nothing to do with mobile. It's a couple of fun findings from a recent test that we did of a legacy application in a client environment, for which we had to do a decent amount of research to actually get anywhere, and I've kind of tried to distill out the more interesting bits of it. So we'll talk about how we worked around some challenges and limitations there, and also, and this is probably the kind of grand reveal at the end, how a lot of hassle could be prevented if people just read a single PDF before they spoke to us. Often the case. So I have to do a little bit of scene setting. I need to tell you about what the application we're testing is and sort of what it means to us. So without further ado, let's introduce Murex MX3. Now, there's probably people in this room who can tell me what Murex MX3 is much better than I could begin to try and explain. So I'll try to keep it down to a fairly low level, but it's an quote-unquote integrated capital markets solution. It can handle everything from the front office, middle office, and back office in capital markets trading. So it basically can look after the entire life cycle of a trade, and then different organizations use different parts of it. Some of them use it through and through, some of them use it for part of the process. That's a lot of words, which I just about understand. Again, there's probably people here who could explain this much better. Realistically, a system like that is far too large for us to fully understand and to fully get an entire depth. We're not here to understand markets trading, we're here to understand application testing. We only have a certain number of days to actually look at the application, and we're working to a pre-agreed scope. So, what is Murex MX3 to us today? Murex MX3 is this beautiful thing, which again gives you an idea of its age and its origins. It's a huge application. It does a lot of things and stuff. There is data coming in, data coming out. Some of it is entered manually. Some of it comes from automated processes. It does things. In our environment, the one that we are currently testing, it is running on Java 7. We think it was probably written on Java 6 or maybe even older, but it runs on Java 7. Good enough. It's normally deployed as a Citrix virtual app, so you normally don't have very direct access to it. But for our testing purposes, we get more direct access to be able to actually interact with it as it kind of is inside of the box. It does client-server communication over a couple of protocols. It has a very complex, bespoke role and permission system. You can see it's got a very retro user management panel where you create, rename users, you provision roles to it. It's complex. And of course, we're testing a very specific deployment of it. So the application itself and any issues that it might have is one thing. Any configuration issues that we might see is completely fair game for us to look for. Yeah, so the client deployment. This brings me to a common point, and I'm basically just squeezing in a bit of a whinge in here, but the testing environment that we often have to deal with when dealing with applications like this tends to be quite exciting. Because what you end up doing is you end up having your own machine, which then connects into a VDI. From the VDI, you remote desktop into a jump box. From the jump box, you remote desktop into a testing environment. then you do your setup, and then you can finally reach your target. And I can already see some nods from the more testing-minded people here. What this means in practice is it takes ages to get anything done. Bringing data into the environment takes about 10 times as long as you think it would, because you have to copy it for every single one of these steps of the chain. Getting data out, same thing. Do you want to type something? Good luck, you've got like 100 milliseconds delay, and everything you type you see appearing frustratingly after you've started typing, and then you go, oh, crap, like I've misspelled 2 words, let's backspace out of that. Oh, now I've overshot. It's great stuff. That sets our scene a little bit. So we've got a legacy application. We're probably expecting there's going to be some challenges there. Not everything is going to be as straightforward as if we just hopped into like a modern web app. We've got a slightly challenging environment on top of that. And also, one thing that I forgot to mention there is the box you get is the box you get. So if you have some tools installed on it, that's probably the tools you're stuck with. If you want to install additional tools, that may be negotiable, but it tends to be a challenge. So knowing where we are, let's talk a little bit at a high level about how we would approach a test like this. And that breaks us into the plan, the 3-step plan. Broadly speaking, there are 3 things that we want to look at during a test like this. We've got step 1, which is looking at network traffic. In this case, we've got 2 protocols to deal with. We've got HTTP or HTTPS. That tends to be fairly straightforward. Again, anybody who's done a little bit of testing probably knows that you'll pop it at something like Burp Suite. You might have to figure out exactly how to make it talk to it, but once you've done that, you kind of get to see traffic. Tends to be pretty straightforward. The one that I want to focus on a little bit more here is Java RMI. And I'll do a quick look around. How many people here know what Java RMI is? A few, not bad. Java RMI is something that I was lucky to learn about at university, which gives you a little bit of an idea. I'm an old man. I was the last cohort in our university who learned about Java RMI. It was at that point already considered obsolete. They just haven't managed to fully update the content yet, so we kind of had to suffer through it, and everybody said, look, just deal with it. So that's Java Remote Method Invocation. It's decidedly old. And what it basically is it's a way for distributed applications to communicate with each other and send around Java objects and Java method calls to each other. It's how we used to do distributed computing 20 years ago. Tooling for intercepting Java RMI it exists. It's just, again, 10 to 20 years old. And if you try to run it, you end up with an interesting case of good luck. We've tried, didn't get anywhere with it, nothing wanted to run, and especially it didn't want to run on, again, the box in a box in a box environment that we were dealing with. So that was off the cards, and we had to come up with a plan. Eventually, we went back to first principles, and we went with the approach of, if we can at least get this into Wireshark, and at least if we can see the raw data, we should be able to start parsing it, because RMI, it's fairly parsable, it's fairly readable once you get to see it. So we've grabbed a Java applet that we've injected into the application to extract the TLS encryption secrets, parse that into Wireshark, you can see traffic. Perfect. We have step 2, which is looking at the application logic. In many tests, and ideally, you would do that through reviewing the source code. In this case, source code was not provided, quite common, often quite frustrating, but we are where we are, we have to deal with it. We're looking at a third-party solution, the vendor is not the client, so getting source code, yeah, tends to be iffy. Luckily, this is Java. Luckily, this is very old Java. Very old Java is easy to decompile. It's literally as simple as you open it in something like JDGUI, a decompiler, and it will spit out at the other end something that looks decidedly like the original source code. You've pretty much got source code. It might be very slightly harder to read. Sometimes people obfuscate the code to make it harder to parse. In this case, they haven't. Beautiful. We can just read the code. We can look at the logic. We can try and understand it. Another thing that you would typically want to do with applications like this is you would want to sort of sit in between the application and the CPU. So you would want to understand what it's doing, and possibly interact with it at runtime. So you'd use something like, let's say, Frida. In this case, I bring you back to my whinge about the environment. That wasn't really going to happen, combined with the fact that in this case, our tooling was too new. So when I was complaining about Java RMI, I was saying, oh, our tooling is too old, I can't get it to run. In this case, the tooling runs perfectly, it just can't deal with an application as old as that, and it can't deal with the Java runtime environment. So if we want to do any modification of behavior, if we want to in any way mess with what the application is sending to the server, we again have to go back to very, very first principles. What we can do is we can decompile the application, modify it, and recompile it. And I'll show an example of that soon. And then step 3, which is often forgotten, and I think it shouldn't be forgotten, is the infrastructure. Infrastructure tends not to be part of the scope of an application test, and that's fine, but that doesn't mean it should be completely forgotten. If you do even a cursory check, if you run nmap, just the most basic tooling, you might find out something about what you're interacting with that you would have otherwise missed. And there's a point to that. So that's broadly our 3 components, and that's broadly what we'll be doing here. This was the boring setup. We can move on to the story. So without much further ado, first things first, we started looking at the traffic of the application as per the plan. We didn't really expect to find very much there, or if we were to find something there, we expected, oh, this is something that's being tested regularly. Anything that's there to find has probably already been found. But we do need to do it, so we're doing it. And quite early on, there is something that catches our attention, which is the presence of a file server. So the Murex HTTP server is something that communicates with the client, and it serves files. So the client might say something like, oh, give me the content of this file, and it's going to be some configuration file. Initially, we didn't see much in it, but it started becoming interesting because the more we looked, the more we saw things that looked like passwords in there. Or they were marked as passwords, but they appeared to be encrypted in some fashion. Might be interesting to find out what that's about. The server was accessible via HTTP and HTTPS, and this is where the infrastructure scan comes into play. The HTTPS server we could see amply in communication between the client and server. The HTTP non-encrypted server existed, but was never being communicated with. We only found it because we ran nmap, we looked through ports, and we went, oh, that looks interesting. Oh, look, it looks exactly the same as this other service. Let's just keep a note of that. There was a lot of sensitive, well, presumably sensitive files stored on that server. There were things that looked to be database passwords. There were things that looked to be user passwords, but they were garbled in some fashion. All of the application's actual binaries were stored there as well. So the way they deployed it is they would give you a very small Java file, which downloaded everything else from the server and then ran that. Mildly interesting, probably worth thinking about. Another thing that's important to think about is that this application didn't behave completely like your normal HTTP server, in that it didn't really respect your standard request types and things like that. So if you just turned a GET request into a POST request, it didn't really care about that very much. What it cared about was those 2 headers that I've highlighted here, Murex extension and Murex action. Murex extension didn't do very much, it just needed to exist. It communicated what, it was an equivalent of the user agent for those of you who know what that is. It basically said, hey, I'm this application. So hi, I'm Murex. And then there was Murex action, which in our observation of traffic was always read. So we were only fetching files, which seems sensible for a client application. So we're looking at all of this, and we're kind of thinking, well, OK, what could an attacker do here with just read access? The fact that we're seeing some passwords being exchanged is a little bit suspicious. Is there anything else? And as we're looking at it, both myself and my colleague Alex, who was also on this test, have this persistent thought that just can't quite leave us, which is, why would you specify an action of read if that is the only action you ever perform? That sounds suspicious. There's probably other actions. We just don't know about them yet. So going back to our first principles approach, we look at our decompiled source code and we ask ourselves, is there more actions? To which the answer is yes. There are quite a few more actions. It actually looks a lot like a fully featured file system because we've got actions which, just looking at them, we can sort of infer, include make directory, write file is self-explanatory, rm is probably remove, and ls probably lists files in a directory. Those sound fairly standard. And yeah, sure, we get something that looks like those commands, but seeing them in source code is not the same as trying to actually make them run and seeing whether we can interact with the server in ways that we previously thought wasn't possible. So can we do these? The answer is kind of. We've got a bit of a discrepancy in observation between the two testers. So I'm looking at it, I've tried writing a file, and I immediately get a file written, I can read it back, it's definitely there. So I go to my colleague and I go, hey, this works, this is exciting, you know, we might have some impact here. And they come back to me and they say, well, I'm unable to reproduce that. I'm trying to make a file exactly how you're telling me, and I'm getting absolutely nothing. And this is one of my favorite parts of doing a test with someone else, is that we've made very slightly different assumptions. So when I was doing my infrastructure scan, I found the HTTP server, which was not being communicated to anywhere else, and I thought, oh, this is a little bit easier for me to communicate with, so I'm going to be using that. Whereas Alex stayed on HTTPS. And this is where we found out that we've made an assumption. We assume that those two servers are exactly the same when they are not. They expose the same backend, but with different restrictions. And largely by coincidence, I hit the unrestricted endpoint, Alex was hitting the restricted one. That took probably about 3 hours of abject confusion and us screaming at each other, being like, what do you mean this is working? It's not. Yeah, it is. Eventually we got there. So yes, the actions do work. And you know, the point here is we can now replace things on that server. We can remove files, we can write new files. So where are we so far? Let's just recap quickly. We know there's a file server which hosts sensitive information. We can find that sensitive information. We don't yet fully know what those things that look like passwords are, but they're named passwords, so we'll probably want to find out what those are. We've also noticed that, again, the HTTP server, being the more privileged one, gives us access to some files which HTTPS was not. There was a small set of files that if you went through everything, you wouldn't get through HTTPS, but you would through HTTP, suggesting that there's some sort of access control there. We can write files. We need to think about the impact of that. And we know that this is true in our environment. We don't know how that translates into the real deployment in real life. So we'll probably want to sync up with that at some point. Those are our 3 targets. Let's split up and search for clues. So let's talk about the writing aspect. We know there's a server. We know we can write files to it. The big question is, so what? There's one approach that I would consider obvious, which is there's a bunch of configuration files. They specify some behavior of the financial things and stuff. If we change it, presumably we can change the behavior of scheduled actions, change how trades behave, or just break the application and make somebody's life very hard. But there is more. I mentioned that it also hosts all of the application files and that those are being downloaded later on. So let's posit a hypothesis. Could we change those files and compromise the clients? So if everybody downloads all the files from the server, if we change those files, they're now running our code. We could make that code anything we want, provided that this works. So let's find out if it does. Let's find ourselves a suitable victim. My suitable victim was the copyright footer of the application. So when you opened the login page, it just said copyright 1986 up until the current year, whatever current year may be, and then a little bit of a blurb about the company. Side note, I can at least claim some youth here. 1986 is still out of my wheelhouse, but that is most likely where the application started. So again, we can decompile it, we can extract it, we can find it, and we can change it. So we changed the copyright footer to "this is a test message from Reversec," and that definitely always said Reversec, by the way. And then from that point on, we have a pretty simple execution plan. So we've decompiled, we've made our change. We can recompile very manually, literally just open command line, run javac, the Java compiler, with our modified file in the context of everything else, upload it to the server, and verify, see if the thing has actually changed. To which the answer is yes. Our footer at the bottom, it is a little gray. I should have gone for the string above it, which was black, but oh well. We can now see this is a test message from Reversec. So we can modify files. We can modify the application files, and they are going to be fetched by the application. They're going to be replaced. So from this point on, an attacker with suitable access, asterisk, could potentially ship malicious code to everybody. That could mean spying on trades. That could mean trying to bypass approval processes. So one part that was very important in this was any sensitive operations performed by one person need to be approved by a second person. Potentially, we could just covertly modify trades. You know, if you're putting something in and the application shows you the right thing, but in the backend just goes, oh yeah, no, actually, let's do this instead. We can do that because we can just modify code. We could probably try and straight up drop malware. You know, there's a lot of things you can do from this little footer. If we've proved this, then we've proved quite a lot more. So I put a little bit of an asterisk on what a suitably positioned attacker is. I'll put a pin on that for the moment, because I want to talk about reading files first, and then we'll loop back because this will apply to both of them. So we know there's passwords, and we've done a little bit of digging to try and understand what the hell they actually do. And the answer is, for the most part, is that there's a bunch of automated tasks that are being run by automated accounts. All of that does username and password authentication. Those passwords, as far as we can tell, are quite accessible, possibly encrypted, but this could still be fine. Maybe accounts are quite low privileged. Maybe the passwords are, you know, maybe those are just password hashes, not encrypted passwords, and they're kind of suitably hashed, and that's what's being passed around. Maybe they are actual passwords, but maybe they are encrypted in a way that, again, makes it somewhat inaccessible to regular users. So with all this buildup, is this actually fine? The answer is no. So again, those of you who are code-minded, if you just glance at this very quickly, you'll see that this code doesn't do much. You can see a couple of shifts. You can see an XOR. Don't worry about it. Here's the actual explanation. So here is how the majority of the passwords that we've seen are encrypted. And I would do air quotes, but both my hands are busy. Step one, you swap the two nibbles in every byte. And to explain this even more clearly, 40 becomes 04, 23 becomes 32. We just swap the two characters for each byte. We then use a key, which is right there in the code. Again, if I go back to the previous slide, you can see LF1999 right here. Coincidentally, that is also an old code name for the application, so it's really, really not secret. And all we do is we perform an exclusive OR operation against those bytes. And then if we decode that back to text, you can see that in this case, the example password was hello with an exclamation mark. So in terms of cryptography, and if we ask sort of how secure this is, the answer is not. That's not how you do crypto. However, this didn't get all the passwords. This was how most of them were encrypted, but there was clearly a second scheme in use. So we looked for that, and that was using real encryption. It was using AES in CBC mode, which is a symmetric form of encryption. Not the best, but at least not the worst. But there is bad news there in that all of the secrets were hard-coded. So again, we can find out what the encryption is and what all the secrets needed for decryption are, which boils down in cryptographic terms to this is just a form of obfuscation. And they were actually honest enough to call this an obfuscator in the code. So with that groundwork, we can now retrieve all of the passwords. We wrote a little Python script. It used the ls command that we saw before to get a list of all the files, download all the files, look for things that look like passwords, decrypt them using one of the two approaches. Honestly, just trial and error. If one doesn't work, try the other one. And we found 234 files with different passwords in them. That's getting into the territory of quite difficult to evaluate, because you now have 234 strings to check. We've identified some of them, and they included admin credential for the application. So, okay, great, we now own the application. The database credentials to what the client described as the everything database. So that's helpful in case the admin credentials weren't enough. And a ton of others we couldn't identify. They had weird names, which I'm sure would make sense to somebody else who deployed the system. To us, some of them were black magic, and we just had to sort of dump them in a file and be like, here's all the passwords. Hopefully they make sense to some of you. Again, this is all assuming that we have enough access to hit those servers to get that information. That was my asterisk for the previous one. That's my asterisk for this one. And from this point on, to actually figure out how realistic this is, we have to speak to the client and we have to see what this looks like in the real deployment. So we move on to a disclosure stage. We call the client and we say, hey, we might have something. We're not 100% because we don't know how things look in your real environment. Can we have a chat? Can we talk about what we found? And can we confirm whether this applies to prod? So armed with this initial knowledge, we talk to the client and we find out a few things. First things first, the HTTP server, that was previously known. They knew that that exists and they closed it out. And they had a vendor validate it and the vendor told them, yeah, this is closed out, this is fine. The application now only communicates over HTTPS. We're not sure what they did. We did get their report, but it just says that they've checked it and that it's been resolved. Very helpful. I speculate that what they've done is they've looked at how the application communicates, HTTPS only, and maybe if we're generous, they checked if the old port under which the HTTP server was is no longer hosting anything. And the HTTP server was still there, just under a different port number. That's why we run Nmap. Production was the same, if not worse. This was a very interesting call that we had, because essentially we had a bunch of internal SMEs from the company there trying to kind of help us unravel it. And at some point, one of them cut us out and just said, hey, I understand what you're saying. You basically don't have to finish, and I've already validated this. And yes, this is as bad as you're saying. Nice. No need to argue. Maybe moderately terrifying, because apparently it's been like that for a few years. But at least, they immediately knew what to do about it. So yeah, server was open as long as you had access to the kind of first step of VDI. So if you had remote desktop within this organization, if you were a user that had an account, you could do all of that to an important trading system. And the broad understanding is that that's been like that for a very long time. It gets worse. During this call, okay, so you can kind of pick up what the atmosphere of the call was by us being interrupted and them going, yeah, fine, this is as bad as you're saying, you don't need to speak anymore. One of the client contacts goes, so when this was being developed, why wasn't the deployment guide followed? To which the kind of consensus answer was, what deployment guide? That's the PDF that would have been very helpful both for us to know, because we would know what we're testing against, and we would actually have a list of decent guidelines for things to look for instead of sort of trying to make up our own methodology. And it would have been very useful for the deployment itself. It's a deployment guide. We got hold of the deployment guide. We went through it. It made the test so much easier. But to be honest, by that point, we kind of already had most of the findings that we were going to get out of it. It would have saved us probably about 5 days of testing if we knew that up front. But it was very handy, and it's very good that everybody in that group now has it. There was more, and I don't have time to go into more, but we had remote code execution over RMI. That took a little bit of bashing our heads against the wall, but it was there. We had authorization checks, which were only enforced client-side. So if you think about a client-server application, one of the core things we always say is everything needs to be enforced server-side because user input cannot be trusted. In this case, everything was happening client-side, so whether a user was allowed to do a thing was decided by the application, which, by the way, we can modify. There was a lack of integrity checking, which made the whole file switcheroo possible. There was the access control on HTTPS. I mentioned that some of the HTTP files were not accessible over HTTPS. There was a way to set up a block list, and they did kind of set it up. It just was nowhere near as tight as it should have been. So I think of the like 230 files that we found, about 180 were still accessible over the server that was supposed to restrict them. And there was a lot more, and if you catch me during one of the breaks, I'm more than happy to go into more details. But that just about brings us to my conclusions. And there's a few of them. I mean, first things first, this was a difficult test. It was packed with traps that were easy to fall into. I mentioned to you, we had some confusion internally at times where I was seeing things, my colleague wasn't, and it happened the other way around as well, where I was making wrong assumptions. This was riddled with traps. And we know that others have fallen into those traps. That's how some of the past findings got resolved while not actually being resolved. And that, I think, kind of brings me to a very big point there, is that a relationship between a security company and a client is really built on trust. And there's a lot of responsibility that comes with that trust. And I'm not sure that that's always as clearly laid out and kind of as highlighted as it should be. So I'm highlighting it here. Perseverance is key. Nothing worked when we started. We got it to the point where it kind of worked. Again, very bare bones methods, but they did the job. And you don't need the fanciest tools. It would be great to have Frida, debuggers, to be able to intercept the RMI traffic in a way that's actually sensible instead of just looking at raw Wireshark dumps. We didn't have that, but we had things that worked. So just use the things that work. And finally, reading the manual would have really helped. And I'll leave you with that. A lot of this could have been prevented with a cheeky PDF. Took us a long time, but we got there in the end. That's me. And if anybody has any questions, I think I have just a few minutes to answer those. So the question was, what kind of privilege do you need to access the file server? On HTTP, the answer is none. If I hop back to my example request, which was in one of the slides, it was in this slide, this is an entire request to read a file. And you can see there's no authentication element here. There's Murex extension, which in our testing, we typically named it something like Murex Reversec test, and then there's Murex action. But there is no attempt at username and password or a session token or anything like that. It's just that. HTTPS was a little bit better in that it used MTLS, so the application had to present a valid certificate to the server, but that certificate was specific to the application client, and it was stored in a key store together with the application. So you're kind of looking at a situation where, yes, it's a slight barrier to entry, but if you have access to the application files, you just grab it and you carry on. Yes. So all Murex actions were exactly the same. On HTTPS, you couldn't perform any actions other than read, and you could only read a subset of files. On HTTP, you could do anything with no authorization. So one of the recommendations there, and that actually aligned with the deployment guide, was the HTTP server should have never been exposed to like every user. It should have only been accessible on a segregated network to some of the server processes which we trust, but never to the user. But it was exposed to everyone.
Thank you. Great talk. I was just wondering, the company, the vendor that created Murex, A, are they still around?
Yes.
They are, okay. And B, if they are, did you contact them? I mean, conscious, these are all features, but I'm sure there were a lot of controls that could be implemented. So.
Yeah, so that mostly fell onto the client because they pretty much own all of the findings, and they did say that they would liaise with them. Some of our recommendations and some of our findings were, go talk to them. But I imagine what will have most likely happened is because a lot of this was covered in the deployment guide, they're going to say, read the manual. Because what was happening is basically the defaults that the application presented were abysmal, but then it told you, oh yeah, these are the defaults, go and change them. So I think that's their approach to trying to fix that.
Hi there. Something used to be, did your client say they had many other Java applications like this, that they opened this Pandora's box?
I'm sorry, I didn't quite catch that.
So the corporate markets, there's a lot of Java applications.
Yeah.
Certainly used to be. Did it open a Pandora's box as to other, more, shall we say, financially lucrative applications?
So there's still a lot of it out there. That still tends to be the bread and butter. You know, you run a lot of old Java. I mean, there's still a lot of Fortran running around as well. And they tend to be applications that were built old and then had other features bolted onto them. So yeah, I would definitely call it a Pandora's box.
Thank you. Fantastic storytelling, amazing, very entertaining. The question is, this is a 1986 application.
Probably.
Very likely. is going to be very difficult to fix, very difficult if you don't rewrite the solution. What are the fixes they are putting in place?
Yeah, so I think in this case, one of the main fixes, and I think you're exactly right, you know, it's difficult to change something that's this old and that's being continuously used. You can't completely replace it because you're going to break everything, which is why the kind of bolting things on tends to be the solution. I think that's why they had a PDF guide, despite the fact that the defaults were insecure, because they were probably expecting, oh, a lot of the environments are going to be that old and they've been set up 20 years ago. People just need to know which settings to check and which settings to change. There are some things that could definitely be re-engineered. I think I mentioned a sort of client-side enforcement of a lot of restrictions. That could be changed on the server. You could require that a user presented and just say, you know, as part of a major update, you do it on both the client and server to make sure that the client knows how to deal with these issues and the server actually presents a response. But it is tough, and a lot of it is down to making sure that if there is a highly privileged service like this, it's not easily accessible, and a lot of it is going with half measures because that's at least something, and at least it solves part of the problem, where a full solution would be impracticable from a deployment perspective.